Hello, today our group will be explaining about our proposal on making wind turbine in Indonesia. So, let's start.
My name is Muhammad Novel Julianto with the name 1020223400417. Currently, Indonesia have been struggling with air pollution. The reason behind it is due to the fact Indonesia primarily uses harmful fossil fuels as its main source of energy production. Fossil fuels have a reputation of being extremely harmful to the environment due to it releasing carbon dioxide. To counter this, Indonesia must turn to renewable energy sources. We propose that we use 3 wind turbines as they use renewable energy source, but also as an alternative to the conventional wind turbines. Unlike conventional wind turbines, 3 wind turbines come in smaller forms. This allows them to be placed in populated areas and reduce costs.
Hello, my name is William Jerry Cook. My NIM is 1020223404426, and I will be presenting about the optimal locations we can place our wind tree turbines in, as well as the overall structure of a wind tree turbine. So to start us off, this, as you can see, is just a normal city, and as you can see, there are trees being planted in that city, and they don't even take up that much space. Now, since our wind tree turbine basically resembles a tree, since it follows its overall structure and size, that means that wind tree turbines can basically be placed in the same locations, which is good because it allows for more options when placing wind tree turbines, and we can even use them as decoration. And they will still produce energy, although not as efficient due to strong winds not being in cities that often. So yeah. And then, so the second optimal location is a mountaintop. So on a mountaintop, the main reason we picked this place is because it's very high up, so that means it's closer to the atmosphere. Now, when a place is closer to the atmosphere and is more open, that means stronger winds usually occur. So with these stronger winds, it allows the turbines to spin much faster and to produce much more energy than if they're placed in a city. This is another picture. It's just to iterate like how tall a mountaintop is based compared to ground level. And this is a beach. So beach is another optimal location because if I play this video, you can see that the water is moving towards the land. The reason this happens is because the air on top of the body of water is much colder than air on top of land. So that difference in temperature causes strong winds to occur. That basically means if you build wind turbines along this coast, that they'll experience stronger winds and thus produce much more energy. And then here's the structure of the wind turbine. So basically I used the Minecraft to build the model. And as you can see, here it is. I'll explain each component of it right now. So this is the, what do you call it? This is the blade. So blade is made of a material called NFRP. Basically NFRP is processed plant produce. So it can be like leaves or grass that's been processed and molded into this type of material. The reason we use that is because it is cheaper than fiberglass and is also environmentally friendly and is also much lighter. That means with a lighter blade, it will be much easier to turn and thus produce more energy than if we use fiberglass or another material. And then we have several components here. So the golden parts, you can see here if you follow the mouse. That's basically, they're called rods. So basically these rods, they connect the pillar to the base of the turbine, and it basically gives the overall structure support because it's holding everything together. And they also serve another purpose that I'll explain later. So these white parts is basically the metal shaft. So the metal shaft's purpose is just to give the turbine structure. It is also to house the cables needed, the components needed to produce energy. And if you can see in the middle here, this orange area, it's basically the dynamo. So the dynamo has two functions. One, as these turbines spin, the rods will cause the dynamo to also move. This movement causes the dynamo to create energy because it has a generator inside it, which creates energy based off kinetic movement. So yeah, and that is the purpose of the dynamo. So all of these components working in tandem will produce energy. And that's it.
Hello everyone, my name is Muhammad Diazak Saputra and my name is 102022340 and I'll be talking about the infrastructure part. Today, we stand at the threshold of a crucial juncture in our pursuit of sustainable energy. As we delve into the realms of wind tree turbines, our vision is clear: to harness renewable energy and power our urban landscapes. Indonesia currently does not have a power grid connecting the islands, but the government plans to create an interconnected electricity grid to support its plan for the net zero emission by 2060. Therefore, for wind turbines located on the coast, we can connect them to the interconnected power grid if it's done. But for now, we will use the main grid, like the wind turbines in urban areas.
Hello, my name is M.Haris with name of 1020223400037. So, the first thing is NFRP. NFRP, or Natural Fiber Reinforced Polymer Composite, is a natural fiber that reinforced by resin. It will be used for the main material for the blades and the body. We estimated we will be using around 600 kg for NFRP, with the prices around 1.8 million to 10.8 million rupiah. The second thing is the metal frame. It will act as the trunk or the base for the wind tree. It also works as the housing for the cables and the battery and other electric stuff. And we estimated the price is around 3.7 million to 7.3 million. The third one is the battery. We will use it to store energy for later use when it is needed. We are planning to use 2 batteries for each wind tree turbine, but we can also add more in the later planning. For the price for one battery is around 2.4 billion rupiah. So for the both battery, its price is around 4.8 million rupiah. The fourth one is Raspberry Pi. It will serve as the brain of the wind tree turbine. It will collect the data of the wind speed and the amount of electricity that made by the wind turbine. And the pricing for the Raspberry Pi is around 1.1 million rupiah. The next one is off-grid. Off-grid is a component that enables independent use of electricity without connected to main electrical grid, and its price is around 6 to 10 million rupiah. The seventh one is controller. Controller with price of 8 million rupiah, it will act as the regulator and manages the turbine to work safely, and it increasing the efficiency and optimal energy production. That's it for me. The next part will be explained by Abiraya. Thank you.
Okay, hello, my name is Muhammad Iqbal Abipraya. My name is 1020223400031. So the 8th item is dynamo, which is a part of wind tree turbine that will generate raw electricity by converting mechanical energy to electrical energy. Around 20 units being required per wind tree turbine, and the cost per unit range from 10 to 18 million. So the total price is 200 to 360 million rupiah. The 9th item is predicted installment cost. It is the cost for installment for wind tree turbine, and the cost per unit range from 50 million rupiah. 10th is predicted wages. It is the cost for assembling a wind tree turbine, and the cost per unit range from 25 million rupiah. To conclude this video, our proposal for wind tree turbine is to provide alternative to wind turbine that is without the negative characteristic of the regular wind turbine, such as that our wind turbine is much more smaller in size, lower setup cost, and operates much quieter. We also want to make people aware about the environmentally friendly technology such as wind tree turbine. Furthermore, we also aim so that Indonesia will be much less reliant on non-renewable energy source and shift to a more renewable energy source. Thank you.